Hello students, lesson number first, rational and irrational numbers. Under this lesson yesterday we seen how to compare the rational numbers, and inside this yesterday I told you this rules discussion on this rule was left, and I told you we will discuss it with the numbers. So here the following rules are useful to compare two rational numbers. Okay, so here if a upon b and c upon d are rational number such that b and d are positive, means this b and this d means denominators are positive. Okay, and if what they told you, a into d, a and b and c and d, if denominators are positive, then if a into d means these two numbers multiplication, a into d and c into b, if we done the multiplication a into d and a into d and c into b, and if you multiply, then if you observe that c into b is greater than a into d, okay, then the c upon d is the greater fraction. So let us see how this is correct. So first of all, for that we will take some numbers. So a is equal to, I will take here 2. Okay, b is equals to b is equal to, I will take here 5. C is equal to, I will take it here, c is equals to 3, and d is equals to, I will take it here, that is 7. Now we will do the multiplication. So first of all, we will put the values in this fraction. Which fraction? A upon b. A upon b means 2 upon 5. A's value is 2 and b's value is 5. So a upon b is equal to 2 upon 5. C upon d. C's value is 3 and d's value is 7. So here I will write 3 upon 7. Now according to this rule, first rule, if a into d means multiplication of 2 and 7 we have to do. A is equal to 2 and this is equal to 6. So 2 into 7 and b into c means multiplication of these both. What we will do, we will change, do some changes here. Otherwise not this rule, we will see which rule follows this fraction. Okay, so first of all what I will do here, 3 upon 7. Now if I will do the multiplication of these both, 7 2 7s are 14 and 5 3s are 15. 5 3s are 15. So you will notice that in this a into d means a into d, the multiplication of a into d means 14 is smaller than 15 means 3 5s are 15. Okay, so you will notice that if you do the multiplication, 14 is smaller than the 15. Now 2 upon 7 means first number's numerator and second number's denominator's multiplication is smaller than first number's numerator, second number's numerator and the first number's denominator. Okay, now here if we done the multiplication, you got it here answer 14 and the 15, and 14 is smaller than 15. Okay, so here 2 upon 5 is smaller than 3 upon 7. In this way also we can compare the fractions. Clear what I said, that first number's numerator and second number's denominator, this multiplication is smaller than the second number's numerator and the first number's denominator, then which is the greater one? That is, suppose this, for example, c into b and c's multiplication is greater than the a into b, then which fraction is greater? The fraction which having the greater value. Now what we will do here, I will do some changes here. A is equal to, I will take it here now, suppose 8. Hmm? Now if I will take 8 here, 8 sevens are 56. So here what will come? 56 will come. Okay. Now if you see here, you will notice that the 56 is greater than 15, and therefore 8 upon 5, this fraction is greater than 3 upon 7. In this way, means from these two examples, what did you understand? The multiplication, if we have to do whichever the fractions they are giving, just multiply the first number's numerator, first number's numerator and second number denominator. Then second step inside, you have to multiply second number's numerator and first number's denominator, and which multiplication is greater, that fraction is the greater one. Okay. Sometimes suppose here I will take a is equal to I will take here 4. B is equal to, I will take it here, B is equal to 5. Okay. Now C is equals to, I will take 8, and D is equal to, I will take 10. Now we have to do the A upon B and C upon D. A is equals to 4, B is equals to 5, C is equal to 8, and D is equal to 10. If you done the multiplication of this first numerator, second denominator, you will get it here 40. Second numerator and first denominator, its multiplication is also 40. Means these both values are same. That time here A into D is equal to B into C. If it is like that, the A upon B is equal to C upon D. In this way, we can do the comparison of fractions by using some rules. Okay, and these rules I told you now only. Okay, here if we have to compare this 9th example, suppose in case. So if I will do the multiplication of this, if I will do the multiplication, 12 5s are 12 5s are 6, 12 into 5. 12 into 5 means multiplication of these both, and then 15 into 3. 12 5s are 12 1s are 12, 12 2s are 24, 12 3s are 36, 12 4s are 48, 12 5s are 60, 15 1s are 15, 15 2s are 30, 15 3s are 45. Okay, now which number is greater? 60 is greater than 45, and therefore 12 upon 15 is greater than 3 upon 5. In this way also we can find or we can compare the fractions. So these rules we use here and we solve the example. From this rule, what we are understanding, we have to do the multiplication of first number's numerator and second number's denominator, and first number's denominator with the second number's numerator, which multiplication is greater. Okay, that we have to note down here, and that side is the greater fraction. Okay, yesterday I told you to solve the 1.2. I hope all of you solved. I think so some only students sent me the answers, remaining student not yet send me these answers. So all of you just complete it and send me on my personal number with your name. Okay, now next it is the decimal representation of a rational numbers. Okay, so first of all some examples are there. If we divide it, what we are getting? The complete number we are getting. And sometimes what happens, sometimes if we divide the fractions, for example, if we divide 2 upon 5. Okay, so what is its answer? As you know that 2 is smaller than 5, so what we are doing, 2 we have to cut and we have to write here. Okay, and we have to take 0 at here at this place. After that, on 2 we have to take the 0 because 2 is smaller, and then give the point here. And 5 stable inside 20 is at which place? 5 4s are 20. So 5 1s are 5 and 5 4s are 20. Means its answer is 0.4. This is the decimal fractions. Okay, and then here suppose 8 upon 4 is written. 4 1s are 4, 4 2s are 8. In this way we are solving the example. So what is given here? Decimal representation of a rational numbers. Under this lesson, this heading, if we use decimal fraction, what they told you, if you use decimal fractions while dividing the numerator of a rational number by its denominator, we get decimal representation. Decimal means answer inside we are getting the point of a rational number. For example, 7 upon 4. Now 7 we divide the 7 with the 4. How we are getting the answers we will see. See here, we have to divide the 7 with the 4. So 7 upon 4. 4 1s are 4. 7 minus 4, how much remain? 3 is remain. On 3 we are taking our own 0, so we have to give the point after 1. 4 stable inside 30 is there? No. Which is the smaller number than 30 which is present in the table of 4, and that is the, if you see here, 4 2s are 8, 4 3s are 12, 4 4s are 16, 4 5s are 20, 4 6s are 24, 4 7s are 28, 4 8s are 32. So you will notice that 32 is greater than the 30. So which is the smaller number? 28. That we have to divide at first term. So 4 6 are 28. Now remains 2. Again we have to take the 0 here. Now we don't want to take any point here. Okay. And 4 5s are 20. So here we are getting, here 1.7. 4 7s are 28. Okay, so the answer is 1.75. In this way we are finding the decimal, and here point will come, then this fraction is called as a which fraction? That is the decimal fraction. Okay, now in this way the some example solved here. Okay, that I shown you how to solve this. Okay, now 7 upon 6. How to divide this? 7 upon 6? 7 upon 6. 6 1s are 6. 7 minus 6, how much remain? 1 remain. This division you are doing in this way also. 7 1 6. 6 1s are 6. Remainder is how much? 1. Here also remainder is 1, that we are writing in front of this number, and here we are writing that below the number. Now same process, here you are taking the 0, here also take the 0. If you are taking own 0, you give the point here, here also you have to give the point. Okay, now point we have to take at this place. Then 6 table inside 10 is not there, so 6 1s are 6. Here also 6 1s are 6. How much is the remainder? Remainder is the 4. Remainder is 4. So here also how much is the remainder? 4. On 4 own 0 we have to take. So here we took the zeros. Then again here 6 6 are 36. Here also 6 6 are 36. Then again we are getting the remainder 4. Here also remainder 4. And that continue again 6 6 are 36. Again 4. Means in this way we are getting the answer 1.1666. This continue if you divide, how many times you are dividing, same number is repeating, and that we are writing in this way. Understood all of you how to divide this in both method? This method is also correct and that method is also correct. But now you are studying in the higher classes, means you are in the 8th standard. So the division, this type of divisions, what happens, it is faster than this type of divisions. Okay, so we have to do the practice of such a type of divisions from this year. Okay, now here you will get the answer if you divide 7 by 6. 1.6666 continually 6 repeating. So that which number is repeating? Okay, 1.166. 1 6, and which number is repeating? On the head of that number we have to give the dot. So the answer is 1.16 dot. The meaning of that dot is the number is repeating. Okay, now here, so this type of, hold on, after dividing 7 upon 4, remainder was 0. Hence the process division ends. But if you divide here when you divide 7 with the 4, you will get 1.75 and the remainder is 0. But here if you divide 7 by 6, so you will get here 1.16 bar. And these are such a type of, if some continuous number is repeating, such a fraction is called as, such a decimal form, rational number is called as terminating decimal form. Means the number is repeating. We know that every rational number can be written in the non-terminating recurring decimal point. Okay, now here if you divide the 5 by 6, okay, 5 by 6, 5 upon 6. Okay, 5 is smaller, so zeros we have to take at first. On it give 0, point give 6 8 za 6 1 za 6, 6 8 za 48, remains 2, 0 take 6 1 za 6, 6 2 za 12, 6 3 za 18, remains 2, 0 take 6 3 za 18, remains 2, 0 take 6 3. Means here also 3 is repeating, that's why on 3 here dot is given. Okay, next is the, if you divide minus 5 with 3, minus 5 with 3, you will get 3 1 za 3, that negative only answer, remains 2, 0 taken. Then 3 6 za 18, remains 2, 0 taken. See, after dividing minus 5 with the 3, after dividing minus 5 with the 3, what we are getting? 1 minus 5 is here. You will get minus 1.666. So how to write this answer? 1 point minus 1.6 dot. Okay, means this is also what happens, continuously repeating, that's why it is called as a non-terminating fraction. If you divide 22 by 7, you will get it here 3.14, 3.142857, 142857. You will notice that this group of a number 142857, this group is repeating, a whole group is repeating, and that's why 3.142857. The numbers which are repeating on the head, we have to give the bar, and this line and that line is called as a bar. That means that group is repeating here. And same thing is here. If you divide 23 by 99, 23 by 99, you will get here 0.232323. So continuously 23 is repeating, that's why here on 23, we on the head of 23 we have to give the bar sign. Similarly, the terminating decimal form can be written in the non-terminating recurring form also. Okay, and that, how to write that? Means first of all, here if we divide the 7 with the 4, we got the here 1.75, and that also we can write the recurring form. And that how to write? Whatever is the answer, that just write 1.75 and on it 0 give, and 0 is continuously repeating, that's why on the head of 0 you have to give the dot. In this way we are converting the rational numbers into their decimal forms. Clear? So today we have completed this part, that is how to convert the decimal representation of a rational numbers, means how to convert a rational number into decimal form. Point, we seen it, and today's your homework is that you have to complete this all practice set number 1.3. Okay, so today we will stop here only. Thus solve 1.3. If you have any question which is difficult for you, just tell me the number. Okay, then I will take that question in our next lecture. Okay, so today we will stop here only. Okay, thank you and have a good day.